Okay, this is for the mini project, especially if you were not in class, because we did it during class, but I know some people had some internet issues. We have done a ton of stuff in the last 2 weeks or so. First, we started looking at patterns like this, and then we extended them, and we noticed this had 5 squares, this had 10, 17, 26. We noticed a pattern of +5, +7, +9. We're pretty sure the next one would have been +11. See if you can make sure you know that. Then we did this lovely super stairs, where first he went all the way up the stairs and back down, and then he went up 1 and down, up 2 and down, up 3 and down. And to get all the way up to the top, he had to do that up, down, all the way to the top. And we made this lovely visual to help us with that. So for the first stair, he took 2 steps. To finish 2 stairs, he had to take a total of 6 steps, etc. And we noticed this pattern here and this first difference, so everything in green here, we called the first difference. We noticed that that wasn't the same, but the second difference was. And all of the patterns that we're working with over the last couple of weeks have a second difference that is the same, and that makes them quadratic. Then y'all took a turn into fence land, where we were 5 meters and 20, 12 and 12, 15 and 10. All 3 of these rectangles have exactly the same perimeter, meaning distance around the outside. 15 plus 10 plus 15 plus 10 is 50. Same thing here, you'd get 50. Same thing here, you'd get 50. But the areas ended up being different. And what we graphed there was we took the length, so either this way with the rectangle or this way with the rectangle, and then the area of it. And when we graphed it, we got this beautiful parabola. Hooray! So again, starting to see that quadratic pattern. For the mini project, what y'all are going to do is you're going to use what you know about extending and following patterns to figure out how many rows can be created. And during class, I encouraged people to ask questions and help each other out. If you're doing this not during class, still ask questions, and you could totally work with a partner if you want to. So what you're going to look at today is something called the toothpick pattern. Let's watch the video. So, as you can see, Dan, this is from a guy named Dan Meyer, has made this pattern with the toothpicks. And what he's doing is he's creating various rows. So the first row are those 3 green toothpicks. The second row are these 6 red toothpicks. The fourth row, whoops, wrong button. Sorry, my bad. I clicked the wrong thing. Are going to be these pink toothpicks. That's the third row, and there are 6 of them, or sorry, 9 of them in that one. And really what I want you to do is in this pile over here, there are 250 toothpicks. Well, total, there are 250 toothpicks. And the question is, how many rows is he going to be able to make? How many rows? So right here, there's 1, 2, 3. There is a Desmos activity for you to do this in. Please, by all means, do that. Just so you know, and I want to make sure that you're all kind of starting off on the same place. In row 1, and we're counting the total number. So in row 1, there are 3, those 3 green ones. In row 2, there is a total of 9, because I'm not just counting these 6 red ones, I'm counting all. If we just look at row 1 and row 2, the total that's used. So in row 3, he's used a total of 18. In row 4, he will have used a total of 30. So see if you can figure out why this next number would be 30 and then continue the pattern. The question is, at what point will he have, somewhere over here, probably further down, will he have used all 250 toothpicks? Your answer does not have to be a whole number. It's just wherever you end up. Let me know if you have questions.